Hello learners, welcome to today's discussion. Today we are once again going through a question on probability, Form 3 Mathematics, a question that was done in the year 2001, Paper 1, question number 23. But before we look at this question, if you have just come across this channel for the first time, kindly take that 1 second and hit the subscribe button so that anytime we produce a video like this, you'll automatically be notified. So let us go through the question. The question we have reads, the probabilities of 3 dart players Akinyi, Kamau and Juma hitting the bull's eye at 0.2, 0.3 and 0.15 respectively. Part A, draw a probability tree diagram to show the possible outcomes. We know that probability is two-sided, that is either something happens or something fails to happen. We have 3 players, that is Akinyi, we have Kamau, we also have Juma. We have the probability of hitting the bull's eye and the probability of not hitting. We are told that Akinyi hitting is 0.2, meaning not hitting will be 0.8. Kamau hitting will be 0.3, meaning not hitting will be 0.7. And lastly, Juma hitting is 0.15, meaning not hitting will be 0.85. There is always a probability of something happening or not happening. So let us represent this information on a tree diagram, that is part A. We are going to start with Akinyi, and we have the probability of Akinyi hitting the target and Akinyi not hitting the target. Hitting the target has been given as 0.2 and not hitting becomes 0.8. We have Kamau, and in total now we have 2 people with 4 outcomes, and therefore we are going to have 4 branches. That is, we have Kamau hitting, Kamau not hitting, Kamau hitting, and Kamau not hitting. Kamau hitting is 0.3, meaning not hitting will be 0.7. Hitting is 0.3, not hitting becomes 0.7. Next we have Juma, that is the third participant, making the total outcomes to be 8. We are going to have 4, that is 8 branches. We have Juma hitting, Juma not hitting. Hitting is 0.15, not hitting becomes 0.85. Juma hitting, Juma not hitting, 0.15, and this one is 0.85. Juma hitting, Juma not hitting, 0.15, and this one is 0.85. Juma hitting, Juma not hitting, 0.15, and this one is 0.85 respectively, for us to get 3 marks for drawing the probability tree diagram. Part B, find the probability that Roman 1 all hit the bull's eye, Roman 2 only 1 hits the bull's eye, and 3 at most 1 misses the bull's eye. This question can either be done through the tree diagram or by using the summary that we have already done here. Since these are independent events, meaning Akinyi hitting does not influence the two from either missing or hitting. And we said under independent events, the outcomes are rejoined using a multiplication sign. So to find the probability of all hitting the bull's eye, we are going to take the probability of Akinyi hitting. We multiply by the probability of Kamau hitting. We multiply by the probability of Juma hitting for us to get the answer. And this one is going to be equal to 0.2. We multiply by Kamau 0.3. We multiply by Juma 0.15. And this one gives us 0.09 as the probability of all hitting the bull's eye. Next is Roman 2 of part B. Roman 2, we are supposed to find the probability that only one hits the bull's eye. Probability of only one hitting. Only one hitting, it means if Akinyi hits, Kamau and Juma will miss, and if Kamau hits Akinyi and Juma misses, and if Juma hits, the two will automatically miss. That is to say, it is getting the probability of Akinyi hitting Kamau and Juma missing, or if Kamau hits, then Akinyi and Juma will both miss, or if Juma hits, then Akinyi and Kamau will both miss. So to go about this, we are going to take the probability of Akinyi hitting, which is 0.2. We multiply by Kamau missing 0.7 times Juma missing 0.85 plus Kamau hitting is 0.3. Akinyi missing is 0.8. We multiply by Juma missing, which is 0.85. We add the probability of Juma hitting, which is 0.15. The other two missing, that is Akinyi missing, is 0.8 times 0.7 for Juma. So if you multiply this bracket, that is 0.2 times 0.7 times 0.85, you'll get 0.119 plus 0.3 times 0.8 times 0.85. This one will give us 0.204 plus we have 0.15 times 0.8 times 0.7, which is going to give us 0.084, and when you add all the three values, you get the value equal to 0.407 as the answer to Roman 2 of part B. Next we go to Roman 3. In Roman 3, the probability that at most one misses the bull's eye, that is the probability of at most one missing. At most one missing, this is the same probability, or it can be interpreted to mean it is the probability of either two hitting or all of them, that is three hitting the bull's eye. So to get the probability of at least two, it means probability of at least 2, it means if Akinyi hits, Kamau hits, Juma will miss. Or if Kamau hits, Juma meets Akinyi will miss. Or if Akinyi hits, Juma hits, then Kamau will miss. Or the probability of the 3 hitting, that is Akinyi hitting, Kamau hitting, and Juma hitting. So this is going to be equal to, the 2 hitting will be 0.2. We multiply by 0.3 times 0.85. We add Kamau hitting is 0.3. We multiply by 0.15 for Juma times 0.8 plus 0.2 for Akinyi. Kamau we have 0.15 times 0.7, and lastly we have oral heating, which is what we have already calculated as 0.09. So if you multiply this bracket, you'll get 0.1, that is 0.051 plus 0.3 times 0.15 times 0.8 will give us 0.036 plus 0.2 times 0.15 times 0.7 will give us 0.021, and lastly we add 0.09, and this one will translate to 0.117 as the probability of at most 1 missing or 2 or 3 hitting the bull's eye. Thank you for watching and welcome to this channel. And in case you are watching this for the first time, kindly we request that you subscribe to the channel so that anytime we produce a video like this, you'll automatically be notified.